Good morning. Welcome to this session. In this, we will be talking about various processes, analysis, and operations used in GIS. We have already discussed in the previous session what is GIS, the basics of GIS. In this session, we'll go forward with the analysis, and this is the section where most of the students find difficulty, and even most of the professionals have problems finding and understanding what exactly is meant by this. So let's start with the first concept. The first concept we will be talking about is GIS processes. So under GIS processes, what we discuss is the first process that is very important in GIS is input. So any information that we are putting into the system, the next step that we need to consider is manipulation of the data, management of the data, then we need to query the data. Based on that, there should be an analysis and finally a visualization. Now let's understand this step by step. For example, I have information about, I have a list of Facebook users. Okay. Now what I want to do is, I want to gather all the information from that user ID. For example, the user ID is AAA, ABC, DEF, and GHI. So these are the four users that I have gathered. So in Facebook, you have unique users. So based on these four users, what we'll see is first we'll have to input this data. Then is manipulation where we'll need to see what are the users. Then related to user, I'll have list of data like for example their contacts, their friends, their videos, and so on. So I'll have to manage this data so that I can access the data wherever and whenever I want. Then I should be able to query from this data. For example, if I want to see how many contacts are there for the user DEF, I should be able to query that out. Based on this, the list of user, their contacts, friends, and number of videos, I can do an analysis. Okay, users from Asia are using Facebook much more than users from America, for example. So that's a kind of analysis I can do. And based on that, I can do a visualization or I can show it on a global map which regions have higher proportion of users as compared to other regions of the world. So if I can say I can mark it by purple, the region which has more users, and I can show it by pink, which have very little users. So that's one way of visualizing what I have understood in GIS. So this is the basic process that is used in GIS. Now there are various steps towards analyzing any concept in GIS. So let's understand the steps in GIS analysis. So whenever you try to analyze anything in GIS, the first and foremost thing is you need to frame a question. What do you want to query or what do you want to analyze? For example, I want to see whether Asians are using Facebook more or Americans are using Facebook more. So that's a kind of framing a question. Then I have to select the relevant data. Then I have to choose what kind of analysis I need to do. Is it related to number of users? Is it related to network, transportation, or whatever it is? Based on the analysis, I have to find out the data processing method, what kind of data processing I need to apply, and finally I have to interpret the results. So these are the various methods, the various steps that you use in analysis of GIS. So this GIS analysis can be done by two means. First is attribute analysis and second is analytical analysis. Under attribute analysis, what is important is I try to question an attribute. For example, there are 10 parcels of land. I can say who owns this parcel of land. So that's a kind of attribute I'm trying to find out. Then there can be analytical question. For example, you have 10 different types of soils. So what I'm trying to do is I'm trying to analyze on which soil will cactus grow the best. Okay, so I'm trying to analyze soil type which is suitable for the growth of cactus. So these are the two types of methods we usually use to analyze any GIS concepts. Now, GIS analysis can be applied to various concepts. For example, in settlement geography, if we talk about, you can use nearest neighbor analysis. So that's one method. The next method is for transportation geography, you can use network distance analysis. Then I can say for settlement geography, again, you can use planar distance analysis. So these are the various applications of GIS. But there are some limitations with the GIS data. GIS can store a lot of data which it is able to display. So abundance of data is one of the issues. Then the scale of data or the magnitude of data is not certain. Sometimes the mathematical calculations required are too difficult for students from social sciences. Then again, there is sometimes there generates or there comes up a need to satisfy many objectives or multiple objectives. So these are some of the issues that need to be discussed. Now, before we go further, let's understand the basic types of analysis. So the first basic analysis we are trying to understand here is spatial analysis. Spatial means space, and analysis means understanding the thing over space. So for example, I have two plots of land, plot A and plot B. If I want to find out what is the optimum route to build a road from plot A to plot B, what can be done? So this is what I can generate from this diagram. So this is plot A, this is plot B, this is the overlying area. So anything which is falling into the overlying area would be the least distant region. So this is one of the methods where you can use spatial analysis or the concept of space. If I say this is plot A and this is plot B, I'll have to find out the distance between the two to find out the minimum distance or the minimum region to build the road. Based on this spatial analysis, what we can do is modeling. Modeling is generating decisions based on what we are spatially analyzing. So modeling basically promotes a decision support system. So for example, if there are two roads, the location is from A to B, and based on that I can decide that okay, the road should be 10 kilometers in length, it should not be more than 6 feet wide. So these are some of the parameters I can define based on the available information I have for the region. The next thing which is required here is network analysis. Now what happens with network analysis? Network analysis is a bit different concept that we need to understand here. So in network analysis, I am trying to find out the network of routes from say A to B, C and D. So what happens in network analysis is there can be nodes. For example, A is a node, B is a node, C is a node and D is a node. Then there can be chains. For example, A to B, A to C and A to D is a chain. And finally is links from A to C and C to B, for example, if I say. So that's a kind of linkage. So these are the three concepts that we usually discuss in network analysis. Based on these three concepts, network analysis has again three elements. First is network tracing. What happens in network tracing? There is a particular path. So for example, A to B, I am tracing this path. So that is what is network tracing. Then is network routing. What does that mean? It means I have to find out the optimal path, or if I can say A and B. So one way to reach B is this, and one way to reach B is this. So I'll have to find out the optimal path or the optimum path where it's most easy or most convenient to reach to B. Finally, the next issue is network allocation. Now, what is important in allocation? Network allocation, you need to designate specific portions. So when you are designating portions, what happens? Designation of portions. So what happens is, I can say, okay, let's say this territory is under city A, city X. I can say B and C are under city Y, and region D is under city Z. So what I am trying to do is I am designating the portions, or I am allocating the networks. Okay, this region would be taken care of by city X, this region by city Y, and so on. So that is what is network analysis. Now we would be understanding the most important concept that we need to understand before we proceed to any practical application of GIS, that is tabular analysis. Now, we have discussed so much so far. The basic concept here is to understand any GIS information, you should have a series of data attached to it. Now, for example, let's understand the word here, tabular analysis. So let me draw a table first. So I have a table here, and that table shows, say, complete address. I have the complete address in the first table. Then I have number of people living in those region. Then I have the county areas that it is covering. So this is one table. The next table, I'll be explaining two concepts simultaneously. So I would be having complete address, and then I would be having longitudes and latitudes. So table analysis is what is known as DBMS, or database management systems. So what happens in database management system? I have complete address, say house number 101 Northwest Avenue. Okay, then I have house number 102 Northwest Avenue, house number 103 Northwest Avenue. So I have 4 such data. Now I have information, 5 people reside in this, 10 people, 2 people, and 1 people. And then all of them are, for example, in Washington County. So I have this information in table 1. Then I have table 2, where I have repeated information of the complete address. So I have Northwest Avenue 101, 102, 103, and 104. Okay. Now based on this, I have latitudes and longitudes, this degree north and this degree east for all these 4. Now we would be understanding 2 separate concepts. Firstly, what is database? So database is any information which is there in the table or in the data systems. Now management systems, how we can manage the system. So what I'm trying to do is I'm trying to classify all information based on this house number. So this address, I'm trying to gather all relevant information. How many people live in there? What is the county which is associated to this? What is the nearby areas? Does this region has the public facilities or the transportation facilities? Is there a climate coming in that region? And all associated information with that address I'm trying to put into this table. So that is what is database management systems. Now I would be explaining another concept, that is RDBMS, that is relational database management system. So what happens in relational database management system is I have 2 separate tables. So for example, this is table 1 and this is table 2. But what we can see in both the tables is complete address is something that is common to both the tables. So what happens is now I can merge this table and this table. How? Because the complete address is same for both the tables, Within this table, I can add another column, that is latitude and longitude. Okay. So that is what is relational database management system. Most of the GIS applications these days use relational database management system, where they can store multiple tables, but for all the tables you have a parameter that is common or related. So ultimately what happens is, by RDBMS you can merge all the tables into a single table, and because just it becomes manageable. Otherwise, for example, I have say 120 parameters. If I try to put it into one single table, it would be too complicated, because when I have first column open, I cannot go to 120 column. If I go to the column number 120, I'll forget what was there in the first column. Okay, so just to make the data manageable, what you do is you try to provide multiple tables, and once you have multiple tables by RDBMS, what you can do is you can merge all these tables into a single table. So this is the two way of using the tabular data. Now, while using tabular data, you can make various queries. So query can be in two forms. First is attribute to query, and next is geometric query. So what is the difference between attribute to query and geometric query? I can say how many people live at this address. Okay, so that's an attribute of that address. So that would be a kind of attribute query. On the other hand, if I ask a reverse question, that at the location A, how many people are living? That means I am querying based on the location. So I am saying what is the number of people living from 101 to 104 Northeast Avenues. So what I am querying is, I am querying a total of this. So it would be 18 people. Okay, but that query is based on geometry or the location. The other query can be, at which location do 10 people live? So what I am doing is, I am knowing this parameter, and based on this I am querying this. So the answer would be 102 Northeast Avenue. So these are the two various different forms of queries that you can do in a database system. And whenever you do a query in an attribute format, it is known as SQL, or the sequential query language. In the sequential query language, you try to do queries into a sequential form from one row to another row. So this was about the tabular analysis. So we have already discussed spatial analysis, network analysis, and finally the tabular analysis. So now let's move on to the various kind of operations. The first operation that we would be discussing today is known as overlay operation. Overlay operation is basically a combination of various maps onto one map. So it's similar to what is a pizza. So you have a pizza base, then you have a layer of sauce and cheese, and then you have the various toppings over it. So similarly is what is overlay. It's basically a combination of various maps or various layers. So overlay can be of two types, raster overlay and vector overlay. We have already understood what is raster and vector in the previous session. So in raster overlay, what happens is, raster is basically matrix of squares. So I have two locations, location A and B, and in this location I have this map, and in this location I have this section. So what would be the resultant raster? The resultant raster would be this plus this. Okay, so this is what is we are trying to understand by raster overlay. We are combining two different maps, and the resultant would be a combination of both the maps. On the other hand, you have vector overlay. So for raster, we'll be understanding some of the operations. Before that, let's understand vector overlay. So vector overlay, for example, there is a square. This is a square grid, and I am adding this to a circle. So what would be the resultant would be, this would be the resultant. So basically I am trying to add the circle and the two lines together. So vector overlays can be in three types. There can be polygon on polygon, where you have one polygon and you have another polygon and you are trying to overlap those polygons. Then you can have line on polygon, as in the diagram shown above. Then you can have point on polygon. So point on polygon would be you have point 1 and a polygon. So it would be this one, the resultant. So these are the various kinds of vector overlays. Now we have understood the raster overlay, vector overlay. But in all these overlays, what is important specifically is the type of operators that we use. So there are various kinds of operators used. Let's first understand the arithmetic operators. Arithmetic operators, this means plus, that is minus, that means multiplication, and this is division. These are some of the very basic arithmetic operators. The next set of operators here are what we call relational operators. Relational operators: less than, greater than, equal to, not equal to, less than or equal to, greater than or equal to. So these are some of the common relational operators. Then you have Boolean operators. You have and, or, nor. So these are some of the common Boolean operators. So and is similar, both 1 and 2. Or means either 1 or 2. Nor means neither 1 nor 2. So that is what are the basic kinds of operators that we use in overlay operations. The next kind of operation that we would be discussing is buffer operations. What is meant by buffer operations? So in buffer operation, what you try to do is, as we said, overlay operations can be used both in raster and vector. Buffer operations can be used mainly with raster, vector data. So what happens with the vector data is, you try to create a zone which is of a specified width around that region. So vector data can be, again, as we know, of three types: point, line, or area. So for example, if I have 5 wells, I can create a buffer around this well. Okay, so this would be the buffer region that covers all the 5 wells. I have a transport artery. I can create a buffer zone around this transport artery, and this would be the buffer zone for this line. I can have a polygon, and around that polygon I can create a buffer zone that would include that polygon area. So these are the various kinds of buffer analysis that we do. The buffer operations, as we know, are done for vector. So what is done for raster? For raster we do distance analysis. So distance analysis is another tool that is used for raster maps. So what we try to do in raster maps is, we try to find the pixels which neighbor a particular set of pixels. So I have, for example, this set of pixels, and I'll try to find out what set of pixels neighbor this set of pixels. So that is a kind of distance analysis, or which is done on raster set of maps. Now a common thing to understand here is digital terrain model. That's an important concept while understanding GIS. What is digital terrain model? We talked about spatial analysis, we talked about modeling. So modeling is basically a decision support system. So with the digital terrain model, what we can do is, we can represent any surface. And when we are trying to represent a surface, we can do it into two forms. It can be in form of isoline, or it can be form of isometric. Isoline is the equal values on the surface. So that is what is isoline. And isometric is a three-dimensional system or a terrain system. Okay, so these were the basic processes, analysis, and operations that we need to know before we practically start to do anything on the GIS software. Now, if you want to understanding these basics, if you want to proceed on to a GIS software, you must be able to know what are the various kinds, what are the popular kinds of softwares that are used. So let's understand or have a brief review about the popular GIS softwares. So let me divide the GIS softwares into two types. One where you can use vector data, or you have the shape files basically, the most popular format. The next is the raster data or the satellite imageries, for example, the remote sensing data, the satellite imagery data. So to do the use the software for raster imaging, the most popular software is UPSC or ADAS. These are the two commonly used softwares for raster images. The commonly used software for vector form are ArcGIS, then you have ArcView or MapInfo. These are the most popular softwares for vectors, and these are the most popular softwares for raster data. So in this session, we have talked about the various concepts in GIS, the processes, the various analysis of GIS, the spatial analysis, network analysis, and tabular analysis, and finally the various operations, the overlay operations and the buffer operations. Hope this session was useful. Stay tuned with us for further sessions on GIS and fundamentals of geography. Have a good day ahead.